Okay, I'm going to go over with you now the Year 12 Summer Further Maths exam on the decision element. One general point about when you're uploading your solutions, it would be really helpful if you just did a couple of things. Firstly, if you do your pictures in portrait mode rather than landscape. And secondly, try to upload them as pictures, so JPEGs or what have you, rather than PDFs. If you upload as PDFs, I can't annotate them. But well done to all of you that uploaded your solution successfully. Now, a couple of things to point out. What I'm going to set you for your assignment for next week, I'm not setting your assignment this week because obviously you've got your other exams to prepare for. I'm going to set you two of the papers that I set you last week, the adapted ones and the final adapted paper. And what I want you to do is to watch this video very carefully and go over your exam solutions. Make sure you learn from any mistakes that you've made. And then on those topics that are clearly identify you need more practice on, do some more practice on those. But be aware the questions I could choose for you were very, very limited. So you are going to need to practice the questions that weren't in that assessment, such as linear programming, graphical solution, filling in an activity network and doing a Gantt chart on CPA, prims. There's lots and lots of things you've covered this year that we weren't assessed on that paper. In the following weeks before the end of term, I'm going to give you a few more papers to do, some of the international ones, just to so you can make sure you practice and get all your Year 1 skills up to speed before we start Year 2 in September. Okay, so on to the first question. This is a very, very straightforward Kruskals algorithm question. It shouldn't have posed any problems whatsoever other than doping mistakes. There was one twist to this question that nearly caught me out when I was doing the solutions, and it did catch one of you out as well. So first thing we need to do is write down the arcs in order of size. So the first one is FJ11, then EG13, then EF15, and then EH17, GH18. Just a little tip for you when you're doing this. Either do this bit in pencil or leave gaps, so if I notice I've missed one out, I can just squeeze it in to write the entire list out again. BC19, HJ20, PD22. It's a good idea to put little dots by them so you know you've ticked them off and you haven't missed any out. FH23, IE25, BE29, AD and DE30. Because they're the same, you're really meant to put them in a square bracket. And then we've got AB, DG, both 32, count square bracket, and finally BH34. And now what you can do is, it's a little bit easier in the actual exam because you've obviously got this printed network that you can draw over. So FJ11, we're going to add that to our tree, and we just put a tick by it, and you just reject any arc that would form a cycle. EG13, EF15, EH17, GH18. Now that would form a cycle, so just got a little cross bar across there. Whatever you did in your solutions was you put a line through it, which was difficult to mark. Don't do that, just put a cross bar or bright reject or not. Just make it really clear that that's not included in your tree. BC19, HJ20, and that would form a cycle. BD22, FH23, cycle, little triangle there, IE25. Now this is an unusual one. I've never seen this happen before where, well, I don't think I have, where two of the arcs cross. But it looks there that you're done, like the whole network is hooked up. But it isn't, because BDC, DBC, is not connected to this part of the tree. So if you went from C to B to D, you can't join this part of the tree. I know it looks like it because of this overlap, and that's a mistake I nearly made, but it's still, you're not finished there. You actually need to also do this one to complete the tree, and then reject all of them. And if you add those up, add them carefully, check your calculator, the weight is 151. It did say there, weight. So a good exam tip for you, when you're reading the question, have a highlighter or something, highlight the key bits that you need to make sure that you cover. Normally on this question, the exam, and it was on the original question, you'd have to draw the tree. I've got it there, but we didn't actually have to do it on this question. And again, normally on a question like this, you'd probably have a part B, D, simple prims. That was question 1, that was out of 4, not out of 3. So originally on the exam paper said out of 3, that was a mistake, it should have been out of 4, so the total mark for decision will be out of 26. Question 2 caused a lot of problems. It's drawing an activity network. So my advice to draw an activity network is do it rough and then do it again in neat. So we've got our starting point. You can label it 0 to real 1 or just don't bother labeling it all. We need to do 3 activities coming off at A, B and C. Then if we look here, you've got B, 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 C. So you're going to need some dummy action going on here. And the trick to doing a dummy is to always do the letter on its own first. So I need to do D and F coming from off B first. E depends upon A and D. So I need, I'll come back to the dummy in a minute. So I need A and D to come together. Okay, and then G depends upon B and C. Now here's where you are going to need a dummy. So you need B and C to come together, but you've already got D and F coming off B. So you need a dummy down to C. And now that's B and C. And you can get cracking with G. Now here's where it takes a decided turn for the difficult. This gets quite hard now. Because if you go to C, we've got G, F, G, E, F, G. So you're going to need a dummy for those two, and then a dummy for the 2 to the 3. And you need to do it in the order, so you do the single one, then the double one, and the triple one. Again, this is the first time I've ever seen this question asked in this style in the exam. So the first thing I'm going to do is give you J coming off G. And then I need G to come together with F, so I can have F and G, because I depends upon F and G. Oh, it's got to be a dummy, sorry. So now you've got G and F coming together. You can get cracking on with I. And now you need E, F and G coming together. So here's E and F. So you need E and F. No, sorry, here's G and F. So you now need the dummy to join that up to E. And now you've got G, F, G, F and E, E, F, G. And you can get cracking on with H. Just check this last one I've got to do. I need H and I to come together. And I can get cracking on the K. And the one thing, what have you got to do? Just type your loose ends. Okay, and then that's the activity node complete. It's very messy, so we can try and tidy up a little bit. So, starting node, we could do B, and then I can do G, dummy up to join F, need A to here, and then I need D, G, another W up to A, then I've got I and H, and then K, and then join up with J. So just make it look a little bit neater. Make sure you've got your arrows clearly on your arcs, and arcs also on the dummies. Okay, last part B course of Laura problems. I hope any of you got B right. It says D is critical activity. So think about that. You must have a critical path. So if that's part of the if that's a critical activity, it must be part of the critical path. Then that must come from here, and then you must go across here. That must be critical. Then H, then K. So that must be a critical path. There's no other way of doing it. So the other critical activities are B, E, H, K. Quite a difficult question though there. I think that bit makes it particularly difficult. Never seen that before. But that's definitely one a lot of you are going to need to do more practice on. Question 3 split up into 2 questions. We've got a quick sort, bin packing, and then randomly a route inspection just locked onto it. Okay, quick sort first. Now with a quick sort, all of you did this part from one of you, we don't have to, but it's really helpful if you do your pivots for each row as you're going along. The reason being, that's the thing the examiner's looking for. You're looking for the pivots, that makes it make the examiner's job easier, you're more likely to get the marks. So we need to identify the middle. Where we have a choice, always go right. So we want descending order. If it's ever quick sort or bubble sort, then a bin packing, it will always be descending order. So you go through the list, writing down the numbers which are bigger than 12. So 17, 14, 18, must be in the order given. 22, 15. One of you wrote these numbers down incorrectly. You wrote 15 instead of 15, you put 5, which completely manked you up, cost you a couple of marks. So 12 was actually in the correct position, so put in a box so it's logged down. And then go through the list again, writing down the numbers in the order given that are smaller than 12, 8, 9, 10, 7. Now that gives us 2 lists of numbers. 18 is in the middle of that list. We've got 2 in the middle, so we'll go right. 10 is in the middle of that list. So working with these 5 numbers first, we write down all the numbers that are bigger than 18 in the order given, so it's just 22. So 18 goes here, lock it down. And then going through the list of numbers, writing down all the ones that are smaller than 18 in the order given. 12's locked down. They're in the correct place now, will never move. Then we go through it, writing down all the numbers that are bigger than 10. There aren't any, so 10 goes here. And then in the order given, the numbers that are smaller than 10. So now I've got 3 sets of numbers. 22 need to be pivoted, 14 and 9. You don't really need to pivot that one because it's trapped, so it's going to stay there, but technically you should pivot it so every number's been pivoted by the end of the algorithm. So 22 is in the right place, 18. Write down all the numbers that are bigger than 14, and they both are. So 14 is locked here, 12 and 10 are locked. Write down all the numbers that are bigger than 9, or none of them. So 9's now locked. So 22 and 18 are locked. 14 to 9 are locked, which gives us 2 sets of numbers. 15 and 7 going right, you must always go right. So now 22, 18, write down all the numbers that are bigger than 15, or 17 is. 15 is now locked. 8 is bigger than 7, obviously. So now everything's locked apart from 17 and 8. So our final two pivots. And obviously they're in the right place because they're trapped. So now that is in descending order. That's sort complete. Okay, part B, bin packing. It's first fit decreasing, bin size 42. Remember, only answer the questions asking you. Like normally you would have to work out the lower bound, but in this question, because I've got a limited amount of marks I could ask you, I cut that bit out. But still, two of you worked out the lower bound. Just didn't need to, just wasting time. So bin 1, bin 2, bin 3, bin 4. I think you could do it in 4 bins if I remember rightly. If not, just put it in bin 5 if you need to. So in descending order, stick it in the first bin, that'll have it. So 22 fits, 18 fits. I've got 40, so I've only got 2 spare, but look, the smallest is 7, so I know, cheat a little bit, I know I'm not going to put any more in there. 17 fits in there, 15 fits in there, that takes me to 32, so I've got 10 spare. So 14 and 12 aren't going to fit, they're both going to go in bin 3. That's 26, what's that, 16 spare. Now 10, now 10 handily fits in here and fills that bin. There's 2 spare there. So where are we? 9. 9 will fit in here. That gives me 7 spare, so 8's going to need to go into bin 4, 7's going to go into there, fills it. So what we've got, 34 left over. So we needed 4 bins. We don't need this for the marks, but you've got, 36 units of waste. Now you might be asked, is your solution unique? One way of showing it's unique is because the total waste is less than the bin size, so you've got an optimal solution. Okay, on to part C, which really is a separate question on route inspection. First thing we need to do on route inspection is identify the odd nodes. Okay, so we've got H, G, B, and I think it was C. Okay, so if we pair them up, so 4 letters are G, H, B, C. So we can have G, H, B, C, G, B, H, C, G, C, H, B. So you've got the 3 different ways of combining those 4 letters. It's a good idea to pick a letter to start with, so I just pick J and then work out your 2 from that. Now here, not a particularly pleasant one. We need to work out the smallest way of hooking up those letters. So G to H, now straight away you can make a mistake, but I think it's direct, but actually if you go through I, it's slightly quicker, and that's up to 25.5. Let's do GB, again, I think it's there, and if you go through the possibility, I think that is the quickest. So if we go through F, that gives me 25.5. G to C, obviously you've got a lot of different ways of doing this, but if you go through all the options, through F and E works out quickest. If you add those up, it comes to 34 through F and E. Okay, B to C, that's the most obvious one, and that is the correct one. 25.7. HC. Lots of ways of doing this, but I think the quickest way is to go through JE. So try your different possibilities, but I think that's the quickest. 36.2. And the one that, when I first did the solutions, I got wrong, and most of you actually got it wrong as well. Most of you did 36.6. I think IF, I think we all did IFB. Actually, if you go through JE, it's quicker. So if you go through JE, it's 34.9. And what you must do, which a couple of you didn't do, is add those up. Let's give you what you would add on to the weight of the network if you repeated those arcs. 51.2, 63.7. Most people got those two correct. The last one, a few you got wrong, so you dropped the mark. So this is obviously the quickest. That's going to add the least amount of weight. So these are the ones you're going to have to repeat. So we're going to need to repeat, not GH, not GIH, GIIH, BEEC. Normally you'd ask, what's the total weight for an extra mark, and you just add on these two together. And then you often get another part where it says you can start and end at different points, but we didn't get asked that on this question. On to the final question, linear programming. This is forming a linear programming problem. So the other type of question is solving it through a graphical solution, which you didn't have to do because that would require you to print off an answer booklet, which I didn't want you to have to do. So make sure you do practice that. But let's go through this one. Now, define the variables is already given. So X is strawberry, Y is vanilla, Z is chocolate. It says, formulate the linear program and state the objective, listing the coefficients, constraints, as inequalities with integer coefficients. Now, somebody that took that to mean the objective had to have integer coefficients as well. It doesn't, and you can't really. Somebody tried to come up with some wacky ways of doing it. So, strawberry is X, vanilla is Y, chocolate is Z. So, P equals 0.75X plus 1.2Y plus 1.45Z. So don't do anything with that, just leave it alone. That easy, you can't put those as integers. Where the objective is to max profit P in pounds, where P equals this. So now we'll just need the constraints. So I'll do some rough working over here. Non-negative constraint the mark wasn't awarded for that, but always do it, can be. X, Y, Z must be greater equals 0. You can't have a negative number of milkshakes. First one, that's dead easy. She'll sell fewer than 200 non-vanilla milkshakes. So that's strawberry and chocolate. So X plus Z, that's non-vanilla, must be fewer than 200. That's a gift mark, really. So 1 mark, 2 marks. 6 marker, you're going to get 2 marks at each of these. Right, she'll sell at most 2.5 times as many strawberry as vanilla. So strawberry is X, vanilla is Y. And forget about the bit where it says at most for now, just 2.5 times as many. So say vanilla was 10, strawberry would be 25, because strawberry is 2.5 times as many. Now if you want to balance that, you're going to need to times the vanilla by 2.5. This is very, very easy to get wrong because intuitively you think 2.5x and y. It's not, it's the absolutely the other way around. It's x and 2.5y because you need to balance those two numbers. Now bring in the at most bit so you can get the inequality correct. So we sell at most 2.5 times as many. So that's at most. So this is the one that can get bigger. So vanilla can get bigger. So you're going to have 2.5y is greater than or equal to x. Now lots and lots of you dropped the mark here because you left it like that. But what you needed to do was double both of them because it's integer coefficients. So we're going to have 5y is greater than or equal to 2x. That's 2 marks. Okay, the last one. At most, 75% of the milkshakes will be vanilla. So 75% of the milkshakes, so the milkshakes are X plus Y plus Z. That's the total amount of milkshakes you make, and we want to work out 75% of them. So that's 0.75 times this, X, Y, Z. And it says at most 75% of the milkshakes will be vanilla. So vanilla needs to be smaller than 75% of the total. Okay, and then if you just bring that one across, so we end up with 0.75x plus 75z is greater than or equal to 0.25y, and then times everything by 4, get 3x plus 3z is greater than or equal to y, or y is less than or equal to 3x plus 3z. so that was another 2 marks. The exam board are quite forgiving in the mark scheme. If you got the inequality the wrong way around on either of those, you've still got 1 mark, which I think is quite generous. Okay, so that was 6 marks, so giving you a total mark out of 6. So go over your answers really carefully, make sure you learn from your mistakes, do more practice on the questions where you've dropped marks, and then go over the questions that weren't asked, because you need to obviously practice those as well. Okay, thank you.